Welcome to the Cement Museum. And come with me on an immersive journey back in time to the year 1920 to learn how cement was made at the Aslan factory. Let me give you a little background. We are in Castellar de N'Hug, and more specifically the site known as El Clot del Moro. Despite its remoteness, this was the spot chosen by the Aslan company, above all because of the very high quality limestone found here, the raw material used to make Portland cement. But also because we have sources of energy here from the water and coal close by. The factory opened in 1904, built as a stepped construction to take advantage of the slope of the mountainside and save energy in the production process. The process begins at the very top, in the quarry, where a fair chunk of the mountain has already been blasted away by dynamite. The quarry workers break the stone down into a manageable size to be transported on wagons as far as the storage facilities at the top of the factory, tipped into separate silos for limestone and clay, the other essential material needed to make cement. This is one of the toughest jobs, above all in the cold winter weather. Here in the dark of the factory, we're a lot warmer. My colleagues mix the limestone and the clay and use carts to tip the mixture into the huge crusher, which helps with the task of continuing to break down the raw materials. The powder emerging from here is fed by a screw conveyor into the dryers to remove the moisture. Once dry, the mixture is fed into the mills and refiners to reduce the particle size and produce the raw powder, which is stored in the silos just before the kilns. This raw mixture of refined material passes from the silo into one end of the rotary kilns, heated to temperatures of almost 2,000 degrees to turn it into a molten mass like the lava of a volcano. All the workers gather here at lunchtime to heat our canteens up. The lava drops out of the far end of the kiln down to the next level, into the coolers, huge cylinders which again rotate to stop the material from sticking together in one big lump. This process of partial melting, which the limestone and clay undergo inside the kiln, creates a new compound which solidifies into what is called clinker, and thanks to the circular motion of the cooler, takes on the form of little black balls which look like coal. Once it has cooled down, it is transported upwards to a higher level using the bucket conveyor. And here it is. Can you see the vertical conveyor? We workers then use wagons to transport the clinker and tip it from the top of the walkway into the huge storage tank, which can hold 8,000 tons of this material. Just beneath the tank are the tunnels where the workers open up hatches to drop the clinker down onto the conveyor belts, which, by the way, provide another way of moving the material horizontally. The belts carry the clinker as far as a shaft. It's here that gypsum is added. This has a delaying effect, giving the builders longer to work with the cement. The mixture is carried up by another bucket conveyor to the silo prior to the final refining process. This silo feeds the cylinder mills which crush the clinker and gypsum into powder to give the end product, Portland cement. Once it's been refined, the cement is carried by a worm conveyor to the 16 storage silos. The same spiral system, this time leading from the base of the silo, then carries the cement on its final descent to the bagging room, where huge machines fill the sacks which we workers then load onto the narrow gauge railway which awaits just outside the factory. Look! The building alongside is where all the women work, performing the task of repairing the jute sacks that the customers send back all torn to be reused. As I was saying, the train runs on a narrow gauge secondary line which the company laid to transport the material. It runs as far as the station in Guardia la Berguedà and links up there with the railway leading to Barcelona, where the market for the product is. But the train that carries the sacks of cement downhill doesn't come back up empty, you know. It takes advantage of the return journey to stop off at the station in La Pobla de Lillet, where it picks up coal brought down by cable car from the Serra del Cacharas mountains. The wagons, full of coal, are offloaded on the right-hand side of the factory, where they embark on their own process. The fuel is taken up a slope to the very top, where the storage silos are. From here, the coal passes through dryers to remove the moisture, and then refiners to crush it into powder. This powder is carried by compressed air along a great big tube as far as the opening of the rotary kilns, where it is injected to create the huge flames needed to burn the raw materials. The kilns are kept rotating by the kinetic energy of water, without first using this to generate electrical energy. The Pelton turbines are connected to the kilns themselves, as well as to the pressure pipe, by means of a gearing system driven by the water. The pipe is the backbone of the factory, with this system of turbines and gearing repeated on each level of the cement plant, tailored to the corresponding machinery. To bring the water to the factory, a pressure pipe measuring almost 5 kilometers in length was laid as far as the waterfalls where the river Llobregat rises. All you have just seen here is a brief summary explaining the scale of the infrastructure built at the start of the 20th century to enable cement production in such an out-of-the-way site as El Clot del Moro in Castellar de n'Hug.